Hey there, welcome back. Got a quick joke for you. This will take you back some years. Why was 6 afraid of 7? Well, because 7, 8, 9. There's an elementary joke for you. All right, here we go. We're still talking about the real number system. Now we're going to talk about the additive inverse, and we're going to talk about absolute value, and then we're going to interpret data that is in tables. So our objective for today, for day 2, let me get my highlighter. Our objective for day 2, I will review how to find the additive inverse and the absolute value of a number. And then we're going to use this information to interpret the meaning of real numbers from a table. All right? We're going to use that to apply it to some real life stuff. Here we go. Again, definitions are really important. You need to know what these terms mean. So when you see additive inverse, additive means that you're going to be adding, all right? So an additive inverse are pairs of numbers that are the same distance from 0 on the number line. Okay? They're pairs that have opposite signs. That's another way to think of it. They have opposite signs so that when you add them together, they always add to 0. -1 and 1, they're additive inverses. Why? Because they're a pair of ones with opposite signs. And when you add them, it adds to 0. -2.5 and 2.5. They're additive inverses because they have the same numeric value and opposite signs. Okay? And when you add them, they equal 0. Right? -4 and 4, when you add them, you get 0. And the reason that you get 0 is because they're the same distance apart but going in different directions. Watch. Here's -1 and here's 1. When you add them together, 0. Here's -2.5 and there's +2.5. When you add them together, you're going to get 0. Here's -4. Here's +4. Same distance in opposite directions, so when you add them together, you get 0. All right, let's try and find some additive inverses. I've done the first one for you. The opposite, or -4, is our first number. We want to know what number we add to it so that it adds to 0. Well, that would be +4. It's the opposite of a -4. The opposite of a negative, that's positive. Additive inverse for 0. 0 doesn't have a sign, so it's just 0. 0 plus 0 is 0. What about +19? It's the opposite of that, so it's a -19. What about the additive inverse of -2/3? You just change the sign. It becomes a +2/3. The additive inverse of 0.52, you just change the sign. It's -0.52. This concept of additive inverse, that's the reason the double negative rule works. Remember when I said you have two negatives stacked in front of each other, it becomes positive? It's because it's adding the opposite. Okay? So the opposite of -x is equal to +x. All right, this concept of distance away from 0, that's the definition of absolute value. Absolute value, highlighter, absolute value, we denote it as an x with 2 vertical lines, all right? It is by definition the distance a number is from 0 on the number line. Additive inverses have the exact same or equal absolute values. So the absolute value of 1, how far away is 1 from 0? It's 1. Right? How far away is -1 from 0? Well, again, it's 1 unit. So the absolute value of -1 is +1. The absolute value of 3 is 3. The absolute value of -3, 3, because it's 3 units away. Absolute value doesn't matter to absolute value what direction it is. It's just distance. Why don't you try 4 and -4 on your own, and then come back and see if you got it right. Okay, the absolute value of 4 is +4. The absolute value of -4 is +4. If you just wrote 4, that's fine too. Remember, no sign indicates positive. All right? All right, on the number line, here's what it looks like. This is the absolute value of 1. This is the absolute value of -1. All right? Here, this is the absolute value of 3. It's 3 units. This is the absolute value of -3. Again, it's 3 units. So the absolute value, the distance, is the same. And this last one, here's the absolute value of -4. It's 4 units. Here's the absolute value of 4. It's 4 units. Okay? The formal definition of absolute value, and it's good if you know this, the absolute value of x, all right, is equal to just x if x is already a number bigger than 0. Okay? So, for example, the absolute value of 9 is equal to 9. All right? You can just remove the bars if this is a positive number. And it also works if it's equal to 0. It equals 0 if x equals 0. Okay? Because the absolute value of 0 is just 0. Okay? Now watch what happens. The absolute value of x is the opposite of x. Don't think of that as negative x. Think of it as opposite. I'm going to try and write that in. Opposite of x if x is less than 0. For example, here's the absolute value of -9. Okay? That is the opposite of -9. It's the opposite of -9. And then that just gives you a +9. Be careful here, okay? This is saying that if what's under the absolute value sign has a negative, all right, then has a negative sign, then you take the opposite to remove the absolute value sign. If what's under the absolute value sign has a negative sign, then you take the opposite, I'm going to highlight the word opposite, opposite, to remove the absolute value signs. The answer of an absolute value is never going to be negative. Okay? When you're done with everything, you're not going to get a negative number. You might get the opposite of a negative number, all right? Unless there's a negative outside the absolute value sign. Okay? All right, so some hints. Okay, we want to treat the absolute value as a type of grouping symbol and simplify from the inside before removing the absolute value signs, okay, when needed. All right, so we have the opposite of, what is the absolute value of -6? Well, it's 6. So we have the opposite of 6. You say, but we can't have a negative number. But watch here, this negative is not inside the absolute value sign. So that means you can have a negative, but this thing can never be negative all alone. Okay? All right? Now we want to simplify on the inside, right? So what is 8 minus 2? That's going to be the absolute value of 6. What's the absolute value of 6? Well, it's just a +6. Okay, why don't you try C? Now be careful of this. This kind of blends A and B together. Okay, so try that on your own. and come back when you have an answer. Welcome back. This is the opposite of the absolute value of, we want to do this first, 3. What is the absolute value of 3? It's just 3, so I have the opposite of 3. Did you catch that? Okay. Be careful when you have a negative out in front of the absolute value. You still have to keep that. Remember to remove all absolute value signs before deciding which number is smaller. So we want to compare 3.5, or I'm sorry, absolute value of negative 3.5 and the absolute value of negative 4.5. Well, the absolute value of negative 3.5 is 3.5. The absolute value of negative 4.5 is 4.5. Which one is smaller? Well, left is less, and 3.5 is less than 4.5. So the answer is the absolute value of negative 3.5, because it is actually closer in distance to 0. Okay? Now we want to compare the absolute value of 5 minus 3 and the absolute value of 6 minus 2. Do the subtraction first. So I have the absolute value of 2 and I have the absolute value of 4. Well, the absolute value of 2 is 2 and the absolute value of 4 is 4. So which one is smaller? That would be the absolute value of 5 minus 3. If you hear my dog barking in the background, I apologize. All right, now we're going to interpret data. The table below shows the percentage change in producer price index for selected commodities. Commodities are like farm products or gasoline, machinery and equipment, iron and steel, electronics. All right? This column here shows the percentage change in price, all right, that it costs the producer to make this product or harvest this product or whatever they do for this product, okay? All right? This is the year 2002, 2003. This is the year 2003, 2004. So for farm products, all right, farm products, the percent of change from 02 to 03 was a positive 12.6%. That's percent of change, okay? So the prices went up 12.6%. In 2003, 2004, the price went up another 10.6%. All right? So gasoline went up 23.3% from 02 to 03, and it went up 24.7% from 03 to 04. Machinery and equipment went down 0.8%, not quite a whole percent, for the first year, and then in the second year, 03 and 04, it went up 0.2%. Iron and steel, positive 6.5%, positive 33.7%. Something happened in this year. Something happened in that year to make that jump really, really high. Oops. Keep pressing the wrong thing. Sorry, peeps. Okay. Electronics. Electronics went down 1.7%. And then went down again 2.2% in the following year. All right, now we're going on the next slide, which you see right below, and mine is on the next slide, so I have to kind of go over. So find this slide, okay? What commodity in which year represents the greatest percent decrease? The greatest percent decrease. So we're looking for a negative number and the biggest negative number we can find, all right? Okay, so we have to look at all the negatives and we have to compare all the negatives. Well, here's a negative, and here's a negative. The largest negative, the one furthest from 0 if it were on a number line, would be this negative 2.2. Okay? It's the largest decrease. So we would say, oh, it's a two-part question. Hold on one second. It's a two-part question. It says, what commodity in which year represents the greatest percent decrease? Well, it was electronics, and it was in 03 and 04. Electronics, and it would be 03, 04. All right, next question. Which commodity in which year, so it's a two-part question, you're going to do a commodity in a year, represents the least amount of change? This isn't asking in either direction. It could be both positive or negative, but it needs to be the least change. So we look back here, and we're looking for a really small change. 0.8, that's pretty small. 0.2, here's the least change because it's the smallest number there. It didn't matter whether it was positive or negative. It needed to be the least amount of change. So that's machinery equipment in 03 and 04. I'm going to abbreviate that. Machine and equip. Again, 03 and 04. Okay, I'm going to change my pen color. Which commodity in which year represents the greatest percent increase? Okay, so we need it to be positive, and we need the biggest positive number. Biggest positive number. Sorry, I went the wrong way. The biggest positive number. I think we identified that when we were discussing it before. 33.7. So that's iron and steel in, again, 2003 and 2004. So we're going to write iron and steel 03, 04. Which commodity had a percent decrease in both years? All right, positive, 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 negative, but that's positive the second year. Positive, positive. Well, here it is, negative, negative. So it is electronics, and we don't have to designate a year because it was both years. And this is just the same question. I apologize for that. I thought I got rid of that. Okay, here we go. These are the problems that we're going to be working in class tomorrow. So please come prepared with your notes and be ready to work and ask questions if you need to. Thanks. Good night. See you tomorrow.